Hello and welcome back to another Walking Talking Mark. This is part 2 of Further Maths 2016 paper 2. So we've got a circle and a cyclic quadrilateral. It says PQRS are points on the circumference of a circle. W to Y is 7 to 5. Okay. And PQ equals PS. Look at the angle X. Okay. Well, I know that W and R add together to make 180 because they're opposite corners of a cyclic quadrilateral. So they add together to make 180, and together they are 12 parts. So if I divide by 12, 180 divided by 12. Oh, I forgot this is a calculator paper. Oops, did that wrong. It's 15. So that means each part is 15. So 7 times 15 is 105. And then 5 times 15 is 75. And then we've got an isosceles triangle here, so 180 take away that is 75, and half it, 37.5. So it's 37.5. It doesn't say give reasons and stuff, so that's all we got to do. Next, solve this. Okay, so I'm going to times both sides by 5. Then I'm going to divide both sides by 2. And then I'm going to square both sides. And that's my answer. Next one. Okay. Now you're going to be really tempted here to divide both sides by x squared. You shouldn't do that though, because that's always a bit of a dodgy thing to do, because if x was 0, then if you divide by x, you're dividing by 0, and that's not allowed. So we have to instead make it equal to 0 and then factorise. So you take the x squared out as a common factor. So now you can see there's two solutions. X is 0 and x is 5. So if you just divided both sides by x squared, you'd have only got x equals 5. So you wouldn't have got that solution. So that's important. Next, we've got makes x the subject. Okay, so let's times both sides by x. Let's expand that bracket. Let's group the x's together. And then factorise the x out to isolate it. And then just divide by that bracket to leave us with x. Alright, a cylinder has base radius x and height y. Let's sketch that out. Whoops. Okay, radius is x and height is y. That's an h, come on. A hemisphere. Okay, radius is 6y, and they have equal volumes. Oh, I didn't print the formula page. I'm trying to save ink. Okay, so let me try and remember the formula. Okay, volume of sphere equals, I believe, I want let's say 4/3 pi r cubed. Or is it just... Oh, oops. Let me just find out. What's the volume of a cube of a sphere? I thought it was. Yeah, 4/3 pi r cubed. So that's going to be, so hemisphere is going to be 2/3 pi, and the radius is 6y. Make sure you cube the 6 as well as the y. Okay, so 6 cubed is 216, times it by 2 and divide it by 3 is 144. Like that, okay. And then cylinder is pi r squared h, so that is pi x squared y. Okay, and they are equal. So 144 pi y cubed equals pi x squared y. Divide both sides by pi. And since I know that y can't be 0, because if y was 0 this cylinder wouldn't be a cylinder, it would be a circle, can divide by y from both sides. So x over y, well, x squared over y squared would be 144. So x over y would be 12. And I don't have to say plus or minus 12 because we're dealing with lengths and you can't have negative lengths. So that's going to be my answer. Angle y is acute. Tan y equals p plus 1 over p minus 1, where p is greater than 1. Which of the statements is correct? Okay, now I know that tan of 45 equals 1. Here, the numerator is bigger than the denominator. So it's a bigger number over a smaller number. Okay, so a bigger number divided by a smaller number is going to be bigger than 1, isn't it? It's going to be bigger than 1. So if it's going to be bigger than 1, that means it's going to be bigger than 45. Because tan graph goes like that. If 45 is there, then bigger than 1 would be bigger than 45. Yeah. That makes sense. You could also think of it as this is the opposite over the adjacent. So we're saying that the opposite is taller than the adjacent. If the opposite is going to be taller than the adjacent, well, the taller you draw it, the bigger this angle is going to become. So that angle would have to be bigger than 45. Okay, work out an expression for sine of y. Okay. You may use a diagram to help you. Oh, well, thank you. Thank you for allowing me to use a diagram. H-A-O. So if tan y is p plus, that's O over A. So opposite is p plus 1, A is p minus 1, and H is going to be p plus 1 squared plus p minus 1 squared square rooted. So sine of y is going to be the opposite over the hypotenuse luckily it allows us to leave a square root on the bottom, but it does want us to expand those brackets. Okay, so let's expand that. P squared plus 2p plus 1 plus p squared minus 2p plus 1. So that makes p plus 1 over square root of 2p squared plus 2. That looks about right, yes? Cool. So that's the answer. The continuous curve y equals g of x has exactly 2 stationary points. The stationary points are a point of inflection at 1, 2. This question came up on paper 1 as well, didn't it? Where you had to draw the curve based on the stationary points. Okay, so we've got an inflection, and then we've got a minimum point when a is bigger than 1 and b is less than 0. Let's just put it there. Okay, minimum. So, oh dear. So inflection needs to look kind of like that. Well, that's rubbish, but you get the idea. Inflection there, minimum there. In an exam I would have done this in pencil and then rubbed it out and made it look good, but you know, label P and Q, so that's P, that's Q. Under the transformation represented by that matrix, the image of A2 is Q. Can Q be the same as P? Okay. The image of A2 is going to be minus 1 times A, minus 3 times 2, 2A plus 8. Okay, and the question is, can that equal P? Can it equal that? Okay, if it did, then minus A minus 6 would equal A, which means that minus 6 equals 2A, which means A equals minus 3. But it also means that 2A plus 8 equals 2, which means 2A equals minus 6, which means A equals minus 3. So yeah, it would be possible. That C looks like an E, let's fix that. That's a nice, weird question. Okay, solve this. Do not use trial and improvement. Like, you know, I said I don't like it when they tell you what method to use. I'm okay with them telling us not to use trial and improvement, because actually, should I be okay with that? You know what? You should be allowed to use trial and improvement if you want to. Except, actually, you know, yeah, I think you should be allowed to use it. I think you should be allowed to use iteration as well if you want to. Maybe I'll solve it using iteration just for fun. No, you would hate me if I did that, so I'm not going to do that. So I'm just making a common denominator, and 3x minus 3 plus 2x minus 4 so that's 5x minus 7. And let's times both sides by this. I suppose I should expand that out, shouldn't I? Okay, so that's 5, right, x squared minus 3x plus 2. So that's that minus that plus that. So 5x squared minus 20x plus 17 equals 0. Okay, I'm alright with that. I like having prime numbers. Oh wait, 3 significant figures. So I'm going to factorise quadratic formula. Minus b plus or minus the square root of b squared minus 4 times... Okay, I'm about to commit a crime and write in this space that it says do not write in, just because, you know, it's YouTube, you know, I have to. 4 times a times c. In your exam, please do not write outside the box. Divided by 2a. Okay. And 400... Oh, why am I even not... I should be doing this on a calculator. In fact, I'm not even going to write the intermediate steps. I'm going to risk it. B squared minus 4 times a times c divided by 2a. So I get 3 significant figures. Is that... And what you should really do is write down all of the, write down the surd, and then also write down the unrounded decimal, just in case you round it wrong. 1, 2, 3. I'm not doing that because I just want to save time. Okay, that's my answers. Ooh. We've got a pyramid with a horizontal rectangular base. B is vertically above x, okay, so x is the centre, I see. V to B is 17, A to B is 22, B to C is 16. Work out the angle between the planes VBC and ABCD. So we want the angle between this triangle here and the floor. And to do that, we need to make a right angle triangle. See, normally when we do angles, it's normally between a line and a plane, and then I say look for the shadow of the line on the plane. Okay, well this triangle, obviously the shadow is a triangle, which isn't going to help as much. So what we're going to do is going to take the centre line of this triangle, and we're going to use that as our shadow. So we're going to be finding that angle there. Okay, so the triangle that we're going to be using is VX. I'm going to call that M, where M is the midpoint of BC. So X to M is going to be 11, and we don't know that, but we could find it, and we don't know that. We could find that as well. I think it would be easier to find V to M. So V to M, if I take the triangle BVC, and I'm interested in this here. So I know that that's 17, so is that. Wait, is it? Yeah. Yeah, it's symmetrical, right? Because it's rectangular. And that's in the middle, so yeah, okay. And then that's 8. Okay, so the angle, well, it doesn't really matter what that is anyway, because I just need No, I don't want the angle, I want the height. So Pythagoras. 17 squared, take away 8 squared. 225, square root of that is 15. So that's 15. So then H, A, O. Cos theta is A over H. So I just inverse cos that. .8. Okay, so if you have to work out the angle between a triangle plane and a floor plane, go for the middle line of the triangle, okay? I need to sneeze, hang on. Right. Ooh, matrices. Shape A maps to shape B by an enlargement scale factor 3 sent to the origin. A to B. Now I know that the matrix for that is going to be that. But if I didn't know that, I could work that out by saying, oh, an enlargement of scale factor 3 takes the point 1, 0 to the point 1, 3. I mean, did I say 1, 0? No, to the point 3, 0. So 1, 0 goes to 3, 0. And the point 0, 1 would go to 0, 3. Okay, so that's how I work that out. Enlargements are easy, it's always just like the scale factor on the diagonal. Okay, and then B maps to C with a rotation of 180. I never remember what this is, okay. So that would go to there, and that would go to there. So 1, 0 goes to minus 1, 0, and 0, 1 goes to 0, minus 1. Oh yeah, because it's like an enlargement of scale factor minus 1, isn't it? Okay. Use matrices to show that the single transformation is an enlargement sent to the origin. State the scale factor. It's just going to be minus 3, isn't it? That's kind of... You don't need matrices to show that, but it has said use matrices. Again, telling you what method to use. I can kind of see the point in that though, because it's not saying use matrices to find this out, which I don't think is a good thing for them to say. But it's saying use matrices to show it, and that's allowed, I think, because they're not telling you have to work it out a certain way. They're just saying they want you to show it in a certain way. I think that's okay. Anyway, so if I wanted to go from A to B and then B to C, I would have to do this matrix first and then that matrix afterwards. So it would be that matrix first and then that matrix afterwards. So I need to multiply those together. Okay, 0. Okay. Scale factor minus 3. I should probably just say even though they've already said it, but just to like confirm it. By the way, in case you were wondering, enlargements with matrices, the centre is always the origin. And for rotations, the centre is always the origin. Matrices can only do stuff that is centred around the origin. That's why matrices can't do translations. Vectors can do translations, but square matrices can't do translations because translations move the origin and matrices can't move the origin. It's just a limitation of matrices. Alright. Which have I got left? It's in a bit of a weird order. Okay, I'll save that for part 3. Okay, I'll see you in a bit.